Hello viewers, welcome to another episode of knowledge sharing. Before we continue, like us, like and follow our Facebook page, subscribe to our YouTube channel, comments and share video for more interesting topics. Today we are looking at this indicial equation, and it says 10 to the power of y times 5 to the power of 2y minus 2 times 4 to the power of y minus 1 equals to 1. Solve for y. So we are going to solve for the value of y in this expression. So we have here solution. So we are given 10 to the power of y times 5 to the power of 2y minus 2 times 4 to the power of y minus 1 equals to 1. We are going to find the value or solve for the value of y. In this case, this indicial expression or equation, here we have different bases that sum up to this equation. Here we have a constant here. Here we have a base 4 here, we have base 5 here, and we have base 10 here. You know, in indices, for us to find it easy for us to solve a particular problem, all of them we must identify or express it in the same base so that we will be able to play with their index values. So in this case, we will try as much as possible to bring all these different bases to the same or similar base so that we can be able to solve for the value of y. So in this case, let's take, for example, 4. 4 is the same thing as 2 times 2, which is equal to 2 raised to the power of 2. First of all, let us substitute 2 raised to the power of 2 in the place of 4. So we have 10 to the power of y times 5 to the power of 2y minus 2 times 2 to the power of 2 into y minus 1 equals to 1. We need to expand the parentheses on this index. So this will become 10 to the power of y times 5 to the power of 2y minus 2 times 2 to the power of, this is 2 times y, we have 2y, then 2 times minus 1, we have minus 2 equals to 1. So here we have 10 to the power of y here and 5 to the power of 2y minus 2, and also have 2 to the power of 2y minus 2. You can see that this index and this index, they are similar. So what we are going to do, when we have, we say note, when we have a to the power of b times c to the power of b is the same thing as a times c all to the power of b. So this is what we are going to do. We have the similar index, so we need to multiply the base and take one of the index. So this will become 10 to the power of y times 5 times 2 all to the power of 2y minus 2 equals to 1. What we've done, we express this in this format. So in this case, this will become 10 to the power of y times 5 times 2, we have 10. Then this is to the power of 2y minus 2 equals to 1. So here will become, and let's recall that in index law, we know that everything raised to the power of 0 is 1. That means 10 raised to the power of 0 or a raised to the power of 0 equals to 1. So this is or a raised to the power of 0 equals to 1. So we are going to substitute this into where we have this. So that will become, so this will become 10 raised to the power of y times 10 raised to the power of 2y minus 2 equals to 10 raised to the power of 0. Because 1 here, 10 raised to the power of 0, anything raised to the power of 0 is 1. So that is what we've just done. So here we can see that we have been able to express the whole of this indicial equation to one identical or one similar base, which is base 10. So what we are going to do now, this other side, we recall when we have a raised to the power of b times a raised to the power of c is the same thing as a times a raised to the power of b plus c. So here, let's express this in this format. This will become 10 raised to the power of y plus 2y minus 2. So this is what it means, equals to 10 raised to the power of 0. Let's do away with the parentheses. We have 10 raised to the power of y plus 2y minus 2 equals to 10 raised power of 0. We have two similar base, so each of them will cancel each other. So we are now left with the index equation or the index expression. We have y plus 2y minus 2 equals to 0. Here we can collect like terms and we add the like terms. We have y plus 2y equals to 3y minus 2 equals to 0. Minus 2 will be transposed into this other side. It becomes plus. So we have 3y equals to 2. We can divide all through by 3. Divide all through by 3. So this one will cancel here. Therefore, our y equals to 2 all over 3. So this is the value of our y, which is 2 all over 3, and it satisfies this expression. If you like what we are doing here, follow us on our Facebook page, subscribe to our YouTube channel, comment and share video for more interesting topics. Thank you.